Hello everyone, my name is Ben and you're welcome to Hackpace. Today we are going to continue from where we stopped. Actually, not actually where we stopped, but we are going to be writing something new today in C programming language. Most of you guys have been asking me, why do I prefer C? Okay, I prefer C because I love C. It's the language that I can boldly say this language is my language of choice, and I love writing code in it. One, because of its efficiency. Two, it's fast. 3 is a low level, and it helped me to gain access to the memory. And it has this traditional way known as procedural programming language, and is generally used to build anything you can ever imagine of: socket files, internet of things, web browsers, operating system, drivers, even write code that operates or controls embedded devices such as electronic components. Okay, so you can see the tons of things that C helps you. And in general, C helps you to understand how computer works. It makes you think like a computer. Okay, so there are a lot of reasons out there that make C the best programming language of choice. Okay, that's why I love the language so much. I prefer learning the C all the days of my life than picking up any other language, maybe like Python or others. No, those are not my thing. Although I know those language, but I don't write code in those language. I prefer writing it in C. Okay, today what we are going to do today is we are going to write a very simple program that will prompt to us to allocate a given memory, a static given memory of an array inside the system, inside our machine, inside our device. Okay, and we write integers, numbers to those memory we allocated. Okay, integers of high and low numbers. Okay, and what the program is going to do is that it's going to print out those integers in ascending order or descending order based on our preference. Okay. Okay, so that is basically what the program is going to be doing, and we are writing this program in a very well structured way, in the sense that, okay, we are going to be creating multiple directories here. Okay, we are going to have the include directories, the bin directories, the lib directory, the obj, which is object directory, the makefile, which is we'll be using to build our program from scratch. Okay, so without further wasting of time, let's dive straight into this video. So I will do Ctrl L to clear the screen and Ctrl U to bring everything to just like remove this text, this bunch of text, bro. So that's it. So first of all, I like creating a separate directory the same way. Make sure you do the same. And if you are watching this video from my TikTok, which or from my YouTube channel, which is the appropriate place you should watch the complete video. Okay, if you are listening to my voice now, either you are using Linux or Windows. If you are using Windows, make sure you have the WXL installed, or you are using Virtual Machine or VMware to run Ubuntu or any open source distro. Okay, you can be using Kali, Fedora, Arch Linux, Manjaro, Parrot OS, Linux Mint, Debian, and so on. Any Linux distro is you are welcome to follow up with this video. But if you are using Windows, please make sure you use what we call WXL2 or WXL. Okay, it stands for Windows Subsystem for Linux. It allows you to run Ubuntu, Kali, or Fedora, or any Linux OS inside Windows operating system. And I think this is only available in Windows 10 and Windows 11. Okay, so let's dive straight into the video. You can also follow this this tutorial using what we call Thermos. Okay, Thermos in your Android phone. In Android, okay, you can use Thermos in Android. Okay, and follow up this video. All you have to do is to install the GCC. Okay, you install the GCC, you install the assembly compiler and the assembly linker. Okay, and that's all. Then you are free to go. Okay, so let's dive straight into what this tutorial is all about. Okay, so Ctrl U. First of all, I'm gonna make a directory using mkdir, which stands for make directory. We're making a directory called Hackpace. Okay, I press my enter key and that directory is created. I will not do cd, which stands for change directory. I'm changing into the Hackpace. Press my enter key, I'm inside it. If I do ls, which stands for list command or list this current directory, is just gonna list the directory which is empty. There is nothing inside though. So if I press enter, nothing is prompted out. Okay, what we are going to do next is to create those multiple directories and the make files and all that. Okay, so I'll do the mkdir again. Okay, so we'll be creating multiple directories. First one will be the include. Okay, the second one is going to be the bin, where our executable code will be, we live in. We also have the lib, because we are going to be creating our own share library. Okay, and we also need the src, where the source file is going to live, and the last directory, which is going to be the obj, which stands for object, where the .o files is going to live. So I press my enter key, ls. Now we got a prompt now full of multiple directories. Okay, these are where operating system software written in C are being built. Okay, they everywhere, every file have where they are being stored, and where they are being stored is a relation of what the file is all about. Okay, just like the bin you can see here now, this bin, okay, we hold the binary executable programs. Okay, why the include, we just hold the header files.
Are you interested in learning the fundamentals of computer programming?
Which is file with .h extension. Okay, it's just gonna hold file with .h extension. The H stands for header files. Why the one with lib, lib, we use it to.
Are you interested in learning the fundamentals of computer programming?
We use it to share, for share libraries. Okay, libraries, for creating share libraries. Okay, that's what we use it for creating what? Share libraries. Okay, and the obj is where the obj is where objects, okay, object files are stored, which is file with .o extension. Okay, that's where they are being stored. The src will contain file with .c, which is our source file in C language. Okay, and that is all. All right, so we are going to create one more file. We are going to call this file the make file. The make file will start with uppercase M, then mkilfe. So which stands for make file. It must start with what? This uppercase M. Okay, that is the best way of writing a make file, creating a make file empty file. Okay, so we just did that. If I clear the screen now, ls, you see we got all we need. So what we're going to be doing next is to change into the include directory and start writing our header file. So header file, we create the empty file. I will just call this pen, since I'm the one writing it. So this will be my own header file. So I press enter. I love using the Vim editor, which is a CLI command line interface editor. So this editor is what I love to use. It's a professional one. It has every necessary keyboard shortcut that you can use for easy access and easy quick typing. So I'll say vim pen.h. I press my enter key, I for insertion key, then we can start writing our code. So first of all, I will use the hash, which stands for preprocessor. I will do if not defined. So what this preprocessor is doing is that it's trying to say if something is not defined, okay, it's gonna look through the system. If this pen, which is in uppercase underscore h uppercase, if it's not defined. So let me just comment this real quick. Say if pen underscore h is not defined, is not what? Defined. So this pen underscore h is just pointing to this file. It's pointing to this file called pen.h. So I will just put this in brackets. I'll just put this in bracket. Okay, it's pointing to that file. Okay, so that is just very simple as that. So if it's not defined, then we are gonna define it, which means if the program search through the entire structure of our device, it did not find this pen underscore h, it's just gonna create it for us. So so we do hash, then we say define pen underscore h. What are we defining now? We are now defining this pen.h. Okay, so I will just comment this real quick. Then we say then define pen.h. okay, which is pointing to this file called pen underscore h, and that is it. Okay, I hope that is clear. Then at the end there we'll do end if. Okay, we need to put the preprocessor, okay, which is the hash. So end if. So what we are just ending this statement here. So we are ending it here. So I'll just comment it real quick. I will say end if compilation end if condition compilation. We say condition compilation. So asterisk / and that is it. So I press enter key, and the next thing now is I will just do a quick comment, because what we'll do here is writing prototypes. Okay, so we say function declaration prototype. Okay, the prototype are just declarations. Okay, declaration of your own written functions. So the first function is going to be called ascending underscore sort, because we are sorting. So it's going to take a integer, okay, an integer of x, okay, which is a string, which of type array, comma, and also it's going to take two arguments though, an integer of n, and that is a full semicolon. So next one also is going to return void, which is descending underscore sort, open bracket, int x, close bracket, comma, int n, and that is it. Then the last is going to return void, which is going to be known as menu, and it's also going to take no argument, which is to pass with void. So these are the three prototypes we just declare here, and everything is correct. So we are done with this function with these header files and prototype declaration. So we come out of this. If we cut the program, we see everything looks good. So everything that looks good, I clear the screen, change. Let us move one step backward by typing cd ... So I press my enter key. So we do ls. Now we are done with the include file. The next thing is to start writing those source file containing in the pen.h, which is the ascending underscore sort and descending underscore sort and menu. So we are now in the src directory. So there is no file here, so we're going to create the file called ascending, sorry that spelling is wrong, ascending underscore sort. It must have a .c extension, and the descending underscore sort.c, and the last one menu.c. okay, so now that file is created. Now you can see we have three of them there. They all have .c extension. So we will start writing our code immediately. So we write the ascending first .c. Yeah, we are going to do some little mathematics here. Okay, so I will just comment this real quick. Okay, this is a way to comment in C / asterisk. I will say function, say function, let us give it the name ascending function definition, because this is the definition, asterisk / and that is it. So the function takes in void, which is it returns nothing, and the name of the function is ascending underscore sort, the open bracket. It accepts an integer of type x, which is of array, and also an integer of type n, and that is it. So press enter and open curly brace, and let us just put the curly brace here though. All right, so first thing is that we are going to create an integer of I, comma j, okay, and comma, I'm going to create another one called temp. Okay, so those are pretty what we need for now. So these are integer variables. These variables are just going to help us for interchange here. So we use it to switch accordingly, so that we can get the higher ascending order of the array and the lower as descending order of the array. Okay, so first of all, we use the for loop. Okay, we say I equals to 0 semicolon. Once I is less than n, which is the number, okay, n is less than n semicolon, then we say I plus plus, or I should be smaller letter, I plus plus. Okay, and we'll press open curly brace, and we press enter. So inside this curly brace is going to be an inner loop. Okay, an inner loop. Okay, so we do another for loop of saying j. Okay, we say j is equals to 0 semicolon, j no, this, first of all, this for loop is just gonna be the for loop that we use to scan in the input from the keyboard and store it in. Okay, so we're gonna say we are scanning F. So we say we scan to so we say what are we scanning? We are scanning number. So we scan %d, okay, comma, we say percent no, we are scanning on the keyboard and we are storing it where? Inside the X. So we say percent, sorry, ampersand S, okay, because that is an array. Okay, so in each first array we are initializing the I, okay, which we are scanning in, and that's all. So we close that and semicolon. So it will repeat until the number it encounters. Okay, so what this does is scan input. Okay, scan input. Okay, we say do /**, we say scan input. Okay, so we comment that. So we are done now. So once we are done scanning the input, then the next thing is to put that input we scan to the internet in the ascending order. So we now create another for loop. Okay, we create another for loop of, we say I equals 0, comma, we say I less than n, we say I plus plus, open bracket, press enter. Another for loop here, we say j equals 0, semicolon, we say j plus 1, okay, hence is less than n, semicolon, we just say j plus plus, and we close that and we open another curly brace and press enter. So within here now is where we are going to use our if statement to check for errors for the comparison. So we say what that we should have scanned in, which is in the S, we see pass in j. J is the second, we are not doing from ascending order. Okay, so we say which j is greater than, which j is less than, okay, also the I. Okay, so then what we are doing here is that we are saying we are not saying temp, we're not saying in temporary, we are assigning the j. So we say x j, sorry, yeah, sorry, wrong typing, x s open bracket j close bracket semicolon. So the value stored in j will not be moved to temp. They will not say the x open bracket I, okay, open bracket I will not be equals to this in j. No, sorry, then j will be equals to that of I, and semicolon. They will not say temp will now be equals to, sorry, they will not say percent open bracket I close s open bracket I say equals to temp. Okay, so this is just like we are doing an arithmetic here. Okay, let me just make this code a little bit cleaner. So put these curly braces here. So we are like saying in this variable temp, which is a local variable, we are storing the value of the second index of the array. If we enter, we will only jump into this statement here if this condition is true. So we say, if for example, since we are ascending I, that means the number is supposed to be arranged from 1 to 3. But if I venture that the j index of j, which is the index of 2 is 1 and the index of I is 2, that means it's not well arranged. So we need to put the 1 in the place of I, and the I, and the 1 in the place of 2, and 2 in the place of I. Then I say if j is less than I, which is true, and we jump into this code here. Okay, then we are storing that value of 1 into temp. Okay, when I say in the j, we are moving the 2 in I into j. J now contains. When I say in the temp which contain the value 1, we are now moving it to the 1. So I can set where in ascending order. So we say we close this. Okay. So
Are you interested in learning the fundamental?
So once we are done with that, okay, we press enter. We also close the second braces. We press enter and we close it.
Are you interested in learning the fund?
We close the last braces. Okay. And I think that is it. So the next thing is to print.
Are you interested in learning
the last thing is to print. So we use the print f statement. We print we say this print is going to be in a for loop dot, so that it can work very fine. So we say I equals 0 semicolon. We say I less than n semicolon. Then we are incrementing I. So press enter. Then we use our printf function to print everything to the screen. So we say we are printing. We say %d new line. Okay, sorry, we're supposed to put the new line in it. So we say new line, and we pass in the x, open bracket I, and close it, and that's all. Alright, so we are done with this code, and we close the curly brace. So this is what this code look like in ascending order. The name is even incorrect, so that should be an error, but let us correct it now. So that is it. We are just done writing this. Okay, we hope everything works fine. But if there's error, we just come back and fix this error. So we have multiple: first for scan, second to check for the ascending order, and third for printing. Okay, so we can just comment this one as well. So we say /asterisk say print values, say values asterisk / and that's all. So asterisk this, I come out of this. So if I cut the ascending order, you see we have everything written well. So the next thing is for us to go to the descending order. .c. Okay, I for insertion key. Okay, so I comment this. I will say descending function definition. Okay, so that is wrong spelling. Definition asterisk / and remember it returns nothing, and the name is descending underscore sort, open bracket. We are taking an integer of array of x, comma, an integer of n. We close that and we open curly brace. All right, so we are creating integer of I, comma, j, comma, temp, semicolon, and that's all. So we need to create a for loop using the I, say equals 0 as we did in the other one. So we are saying once I is less than n, that's true, then we are incrementing. I should be lowercase. We are incrementing. Then we.
Are you interested in learning the fundamental?
We press enter. Okay, then we are scanning now. So we use this scanf. Open this %d. Open this comma. Then we say where are we scanning? We are scanning from this, which should be in ampersand x.
Are you interested in learning the fundamental?
Close the bracket, close this semicolon, and that is it. So I will just comment this real quick. We say /asterisk scan input. Let's just call it scan input asterisk / just as we did in the ascending order. So now we are creating another for loop of the of where we do the descending order printout. Okay, so we say I equals 0, I less than n semicolon. We say I plus plus, we close that. Okay, this another follow, we say j. Okay, this is an error here, so it should be equal to. Okay, yeah, an error again, it should be semicolon. Thank God I'm seeing this error now though. So we have to say j equals 0 semicolon j plus 1, hence j plus 1 is less than n semicolon, then j is incremented, and we close that. And now we can now do our testing. So we say if x open bracket j open bracket j, which is the second one, is greater than, we're just like flipping it. Your ascending was less than and this was greater than, because we're doing it in descending order. So once it's greater than x I, okay, xi, then we say we are enter open, so we will press the enter key, open curly brace, and we say temp. Okay, temp is equals to x open bracket j, okay, semicolon, and we say x open bracket I, you see x open bracket j is now equal to x open bracket I semicolon. Then we'll now say x, is this correct? We are moving this to here. Okay, and so if this is greater than this, okay, we are moving it to temp, and we are moving the one of I to j, and we are moving temp to I. Okay, yeah, so we are doing x I, and here we pass in temp. Okay, that's correct. So this code is done, we close that, and we close this. So the next one is to write another follow that has to do with the printing. So we say I equals 0 semicolon I less than n semicolon I plus plus. Okay, these are way free programs are being written. So whatever you test in the condition, know that the value remain the same. Okay, so we can use I multiple times here, because the value always return back to what it is once it's out of the condition. Okay, all right, so we are printing, you say %d /n, close this, and we are passing x open bracket I, and we close this. So we say asterisk, we say print values asterisk / and we press enter, and we close the last one, and that is it. Okay, so that is it for this function. All right, so we are out of this. So I'm really doing this thing real quick. Okay, so so that is okay, you can see we clear the screen. We have now written the ascending and descending, so it remains the menu. So the menu dot c, okay, say I for insertion key, just comment it. So we say menu function definition, okay, asterisk /. So it takes in void, the name is what, menu, and it accepts what, void. And this is just to print a very beautiful menu for us on the screen. So we use printf. So asterisk /t/t, we say multiple asterisks here, /n, we close this, and new line. So what I'll just do here, I'll just copy this line. So I'll do escape YY, that has been copied, and I'll just press I for insertion and press enter, and press escape again and press and press I again to just like give a tab, and press escape and press P. Press it again multiple times to get this look for us. Okay, I think this is okay. So I press I. So I just paste. That is what you call copy and paste in the terminal. Most of you might not know, but that's how it looks like. So inside this, I'm just gonna do some editing here. So I'm gonna come here. Yeah, I'm just gonna do some little editing here. So I'm gonna do here. I'm just gonna type in menu. Okay, yeah. So the next one here is gonna be here. I'm just gonna remove. So I'm gonna say 1 is for ascend. Okay, and that is it. Come down here, just gonna delete. You say 2, you say is for descend, and that is it. And we say 0 is for exit. Okay, we say for exit, we put it in uppercase letter. So if you press 0 is for exit, put this like this. So, and that is it. And these are the 2 last one. Press enter and press escape and tab I again, tab escape. I will just press that P again to paste one more time. I just do backspace, and that looks, I think it looks good now. Now I have to do some little editing here. Okay, we'll do some little I think this look good. Come here, I'll do some little editing here also. So just come here, press enter, escape. Okay, and I will press P. Okay, and I for insertion key, I will just go back, and that is it. So this is all we pretty need for this. So at the end of it, I will just put my enter key and close the curly brace. Close the curly brace. I'll save this code. So that's all we need for the menu. So guys, we are done with writing the ascending, descending, and menu functions. Okay, so we just do one step backward. The next thing is we are not gonna start writing our makefile. So our makefile will depend on binary execution. We depend on creating a shell library and the objects. Okay, so I will say vim make. Okay, so I'll say we start our makefile first. I for insertion key. So the name of the program is going to be sorting. Okay, sorting. Okay, yeah, it's going to be sorting. So that there's one more .c file we are going to write, but let us write the makefile first. So the makefile will depend, this will be called, okay, let me don't should I use make all? Yeah, I'll just do all. Okay, so if I say make all, it's going to make the sorting. Okay, under this sorting is where we generate the shell library. Once everything is done, we generate first the library, which is VGCC. Okay, let me show you something, guys, before we continue. Make have a way of structurizing things. First of all is the target. We have a column, then we have the prerequisite. Okay, then after the prerequisite, you now have the recipe. Okay, so this is how these three is how makefile is being organized. So this all here is the target, this is a prerequisite, and this is a recipe. So the recipe cannot execute outside when the prerequisite is not done. Okay, so we are going to follow this method. but let me just delete this, but just note that. Okay, so go down. Yeah, so to create a shell library, we say gcc minus shared. Okay, that should be the name. So dash o to ./lib should be where the shell library should live. / the shell library should be pen lib.so. Every shell library must have a .so file. So this shell library is gotten from the object code, which will live in the ./obj. Okay, / all the file that end with .o extension. Okay, all the file there that end with .o extension. Okay, so and that is it. After the shell library is being done, then we use the gcc to get our output. So we say gcc we are compiling the ./source/ sorting. Okay, and we are outputting it to the ./bin/ the name called sorting. Okay, so this sorting we have .c extension. .c. All right, so that is it. So this is our make rules now. So the first thing we are going to write here is the sorting. So now we give it the prerequisite, which we base on the object code, which is ascending. Sorry, that was wrong spelling. Ascending underscore sort.o. Another one is the sending underscore sort.o, and the last one is menu.o. So these are the three files. Okay, and these three files has a recipe. Okay, so the recipe is how these three files are being generated. So we do gcc, shall we say dash minus f dash minus uppercase f, no, smaller case f, then uppercase I, PIC, which stands for position independent code. The PIC stands for position independent code. It helps us to generate this .o file. Okay, so we say position independent code .c.
Are you interested in learning the fundamental?
See, position independent code -c is generated with the file in the ./source/ asterisk. Okay, we'll pass in the file one after another. Okay, let me take this object file out of here, and this library out of here. Let it just be the final executable file. So we'll just put that shell library here. So we do shared. Okay, so we do -o, we say ./lib. We want to store it in lib. The name is pen.lib.so, and it's gotten from the ./obj/ everything asterisk.o. Okay, and now we are creating the ascending underscore sort.o target. That is our target. Okay, so it's not going to have a prerequisite. So we are generating these targets from the source file. So we say gcc, we say minus fpic space minus c, and the name of the first one is ./ is in this directory source, and its name is ascending underscore sort.c, and we are done with this. And we have the descending underscore sort.o. So it has no we're not giving any prerequisite there, so we say gcc dash fpic dash c, we say ./ in the source directory called descend descending underscore sort dot c. Okay, the ascending, creating this file, it will need the header file. Okay, so we are including dot forward slash we're just including the pen dot h. Okay, yeah, we're just including the pen dot h there. Also here we are including the pen dot h also, which is in the include directory. Prerequisite, we don't need include directory in prerequisite, so we leave it like this. If this doesn't work, we just come and fix the error, but I know it will work. But if it doesn't work, say menu.o, press enter. We also need the pen.h, press enter. So we say gcc minus fpic dash c dot forward slash source forward slash menu dot c, right? And that's it. All right, so the next thing now, we are going to create a make clean. This is for cleaning our program, which is rm-rf. Okay, we are cleaning in the dot forward slash obj forward slash asterisk, whatever that stands with dot o. We're also removing the minus f, say dash forward slash bin forward slash the sorting program. What else should we remove again? The rf dot forward slash lib forward slash pen lib dot so. Okay, so anytime we run this make clean, it will just delete this file. We run make all, it executes all this for us. Okay, so this is a very simple rule. I didn't put most of the make short keywords. I just make everything plain so that everything works very fine. So this code here will execute when this one is done execute. So when you reach this one, prerequisite, it jumps to here, and this code here library will not execute it. All these ones are done executing. So it will jump here. Okay, it will jump here. Okay, and jump here, do here, and do here. So once it's done, if we run make clean, everything will be clean. So I think we are done with this. Okay, so the next thing is to go and create our source file. So we have in the make file, our make file, we have in the include file our header file, and we have in the source file our source file. We also need to change to the source again, where we write our main program, okay, which is called the source. We use touch to create it. We use touch to create, which is called the sortin.c. Okay, so use vim to open that sortin.c, I for insertion key. So now comes in making use of those of our header files. There are mistakes we have made, which once we are done writing this file, we'll just correct those mistakes, or let's correct this before we start writing this code. So I'll do escape this, right quit, then I'll just do vim ascending order. We are supposed to, since we use this printf function, since we make use of the printf function here, okay, you can see the printf function here, and the scanf, you can see the scanf. We are supposed to include, okay, we are supposed to include the stdio.h. Okay, so that everything will work fine. We do the same in menu. In descending, we're supposed to also include that. So we do hash include stdio.h, close that, and we also do it in menu also. We say I for insertion, we go at the top and press enter here, press enter again, hash include stdio.h, lib.h, and we close this and we are done. Okay, and that is it. So now we go back to our sorting.c. So we start writing our code. We are going to do a lot of mathematics here though. So we are including stdio.h. We are also including the stdlib.h, and we are also including the one we wrote, which is in // we are moving one step backward, which is .. include /ben.h. Then we close that. Okay, I hope that is understood. Then we are creating our main function, which accepts nothing from the terminal. So we pass in void, and we open this, and we say return 0 semicolon, and we close this. It's time to write our code, guys. So yeah, now we are gonna do some little mathematics here. Okay, first of all, we print to the screen all right, let me put a new line here. So we print to the screen, print f, we print double new line, okay, just for beauty's sake. And the first thing we are going to do here now is there's a program we need to install. So I don't know if you are using a desktop, a laptop, or your Android phone. So I want to make this program to be smart, to detect if you are using a smartphone. It will detect that you are using a smartphone and install that program for smartphone, okay, which is Android. If it detects that you are using a laptop, it will install that particular program again for laptop. Okay, so I'm just gonna create a scanf. We'll create an integer of we just call this decision. We'll call it decision, yeah, call it decision. I for decision, yeah, decision semicolon. So I'll just come here. So we print new line. We're going to print to the screen, printf. We say press, we say installing, we say installing in uppercase letter Figlet. Okay, installing Figlet. No, it will print this installing Figlet. Oh, sorry guys. So what's going on? So we are saying installing Figlet \n, okay, another \n, and we close this. We are now, oh sorry, we put semicolon. We are not doing another printf here. Okay, what this printf will now do is that it will tell you that make a choice that you should press, let this first I be uppercase, let it be uppercase I. Okay, say press open brackets, press 1, press 0 for Android. So if you are installing Android, you press 0, or 1 for laptop. That means if you are installing it in laptop. Okay, laptop is same thing as desktop/desktop. So I'm just make this thing more smaller so that you can fit the screen. Okay, put column here, make it a little bit smaller again, and we close this. So that is it. So whatever you scan in now depends on what will be installed. So do %d. Yeah, so we are passing the address of decision. We say decision. Okay, and we close this. So whatever you enter, we'll use the if statement to do a condition check here. We say if decision, okay, is equal to 1. Okay, if decision is equals to 1, then if decision is equals to 1, then we enter here and run the program called system. We say the one is let's say 0 first. If decision is equals to 0, okay, now we are installing in Android, so we say apt, that means inside your TMOS, apt install the program called Figlet. Okay, apt install Figlet. All right, it will be good we first of all run apt update. Let's put this like this. So we come here, we say apt update and apt upgrade. Okay, so that it update and upgrade it. Semicolon, we press enter. We also do another system. Once that is done, it start installing a new thing also. Using apt, start installing the Figlet, and once that is done, that program close. But else, if decision is equal to 1, okay, if decision is equals to 1, and that means now we are going for system, we are installing for system. So we say system, and we now say we say super user do apt first. We do update, so that it updates your system for you if your system is not up to date first, and we close it, semicolon, press enter. Another system, there is a command called exec which you can use, but I don't want to just pass through those hustle of using exec, so we just use this apt. We should have just done them together in the same line, and we say and super user and apt upgrade. Okay, yeah, and apt upgrade, or we can just do them in separate line. There's no arm. Okay guys, there's no arm in that, so that you understand everything. So we'll do another system, sudo apt upgrade. Okay, and semicolon. So once that is done, the system will now install this system. Using this system call is very easy. Okay, but there's a way I would have loved to do using the exec family function, but for simplicity's sake, so I will just use the system. So we are now installing Figlet in your system, and that is it. So we close this, then else if you do not enter any of this, then we say else input print to this print to the terminal. We are just printing using printf. We are printing to the terminal wrong input. Okay, and we do backslash n, and we close this, and we also call the exit family call of exit. You want it to exit with a failure, so that you give a wrong input. There's a way we have do it. We just like make it more robust by writing a program that can repeat itself. Okay, you can write in a program that can repeat itself, but let us just make things simple here so that this program will not be that push. Okay, so I press enter and I close. So if none of these two conditions is satisfied, then this else will be executed. So once we are done with the installation here, the next thing is to print again, new line. We use printf. We are printing again /n, and we close this semicolon. Then the next thing is to start up the system start up the Figlet, and we say sort in is the name of the program. Okay, this should be in double quotes. All right, so and that is it. Okay, now we have gotten the Figlet. The next thing is to now choose the input, either ascending order or descending order, which we want to choose. So it's time to call the menu. Okay, we call the menu function. So we say menu, open and close brackets. So we call the menu function, and that is it. Yeah, before we call the menu function, let's do a printf. Let's do a printf here, just for new line, and that is it. So we call our menu. So once our menu is done, it prints the menu. It's now time for us to start making choice of what we want. So first of all, we are going to scan in into another, we call it choice. So I'm going to create an integer at the top of my program here. Okay, at the top here we'll add another one called choice. Say choice, yeah, which is of type integer. So we come down here, so we say choice. We want to print f to the screen. So we are saying we say enter. We say enter your choice. We say 0 to 3. 0 to 3. All right, so that is, so whatever number you enter will be the number of choice that the program will start. So after that, we now scan into choice using the scanf %d, and we pass in the ampersand choice, and we close this, and that's all. So the number we scan in now will not depend on what we choose. Then we are using the switch statement here to say choice. Whatever choice is, then we are doing a case here. So case 0. Okay, then we are calling the if the case here is 1, let's start from 1. If the case here is 1, then we are calling the ascending that spelling is incorrect. We are calling the ascending underscore sort, which takes in x of array, comma, and n. And after that is done, the program break. We write another case 2. Then we call, that means we are choosing descending underscore sort, which takes in that of array, comma. No, we just passing x, not array. We just passing x. We just passing x. Yeah. And semicolon. Then yeah, we are supposed to put a break. And we are now saying case, it is now 0, which we now call the exec function, which will now exit with success, because you are the one that yeah. So the other place we enter exit, was it success? It should be failure, because you enter wrong input. It should be exit failure. Please correct that. Okay, correct that in correction, please. Okay, so this will be exit 0, because we decide to exit the code. So the next input here will be default. So if none of these things you enter, we just exit also successfully. If none of these enter, we exit failure again. We exit with exit code failure, because you didn't enter the wrong, you enter a wrong value, failure. And we close this. Press enter and close the switch statement. Okay, another thing we're going to do now, the ascending here. Okay, the value here, we have not yet given it the actual value. Okay, and we have not yet wrote about the allocation of memory. Okay, so now after we have entered choice here, this is where we'll now talk about the memory allocation. So first of all, I will create now we create an integer of n. Okay, at the top of our program here, we just include n. We include n, we say comma n, okay, which is what we are passing through. Then we'll come here, we'll now say print then after we enter, we'll now say print f. We'll now do double tab, we'll now say allocate memory size, please. Okay, so we're telling to allocate memory size, please. Then it will request a prompt here, request an input here, so we are using the scanf again. Okay, so we do %d, should be %d, and we should pass it to the n. Okay, and we close that. So whatever value of the n will now be the size of our array. So integer s array should be a size of n. Okay, I hope this is understood. So that was how we get the location, and that is how we allocate the size. Okay, and that is it. Is this program done? Yeah, before we now enter our switch and it does the ascending and descending order. Okay, so I think we are done with this program, guys. So let us run this program and see if everything works as we have written it. So I'll do escape shift WQ. No, that should be smaller letter W. Okay, so we are done writing every program we need. So we'll do change dot ls. Only place I've not written anything is in the lib and the obj and the bin. So sorry, the lib, obj and bin. So these three directory now will depend on our makefile. Our makefile will be the one to generate these three files for us. Okay, so we clear the screen. So how we build this program, we type make all. If there's any error, then it will tell us. Okay, no rule to make target pen.h needed by ascending.o. So that is how we first get our first encounter of error. So I will do the vim and we'll go to our make file. Okay, we're creating our source code here. Say no make rule for this. Say I'll just remove this and I will remove this. Okay, yeah, okay, so let's run this program and see. Oh, it's not gonna work proper. So W for write. This place we wrote execute program, we need to include it the dot /lib please add that /pen lib.so. So it should be .so. So we need to include that object file. Okay, that's share library. Okay, so I'll press this and if we type the make all again, clear the screen, make all again and press enter. Let's see. Okay, it's now saying the menu.o stop. Okay, because the menu.o do not have root for this. So we change into source to fix that. So menu.o do not have a rule. Oh, didn't we include a show? Let's check that in our make file. Vim underscore make. Okay. It's generating this. Oh, sorry. So we have to remove the .h file here. Okay, we don't need a rule for this file. Remember when I told you we were writing this make file that we don't need a rule, so we just type make all and see if everything works fine. Okay, so no source file or direct record object.o /**o. Okay, I'm doing a mistake there. I went and put comma. Wait, let me see. All right, making this share library outputs ascending. Okay, it's not why is it not okay? There is no file there. Okay, there is no file. When the this ascending order is being generated, we are supposed to like move it. Like when we say -o, you're supposed to like move the object code to the other directory where it's supposed to store. Okay, you're supposed to like move it. So we say mv from the /source. Okay, / we say ascending. Okay, underscore sorts .o. Then we are moving it to dot forward slash obj forward slash. That's where we are moving it to. The same thing, so I will just copy this line of, oh no, there's no need of copy because the files are not same. So I will do the same here. I will say mv dot forward slash source forward slash send, sorry, should be descending this time around, this sending underscore sort dot o. Then we are moving it to dot forward slash obj forward slash. The same thing is also applied to the menu. Press enter. So you see mv dot forward slash source forward slash menu dot o. We are moving it to dot forward slash obj forward slash, and that is it. Yeah. So this code now will not be recognized very well. Okay, so escape. We do this. Although if you list the source now, I think you are going to see the object code there. Okay, there's no object code there, so we just type make all. Let's build it again. Say no such files like gcc done, no such file or directory o dot forward slash obj forward slash asterisk dot o. Okay, maybe order of the order in which we arrange the file is not corresponding. Okay. Okay, let me just do it this way. Let me copy this file, escape, yy, then I will just and delete it. And just delete it. Then at the top here, I will just add lib, and I will go down here. At the bottom here, I'll press enter. I'll say lib column. I press enter. I press escape. Press P, and I paste that. I for insertion key, just tab. You end here, or press enter. So let's run this code and see what happens. Make all. I clear the screen. Make all. Okay. All right. It's saying dot forward slash o source dot c output so dot bin dot forward slash o. No such directory like dot forward slash lib dot make. Okay, line 3 is where the error is coming from. So we go to line 3. Okay, this is line 3. We are compiling this. Okay, let's take off this let me copy this file as well. Yy, come down here, press I for insertion key, press enter, press escape P, I, backspace, and tab. And I go up here and I delete this line. I delete this entire line. So let me run and see what happens. So we just type make this time around, don't make all anymore. So so we are still getting the same error. So let's fix it now. I think it will be more easier to fix now. So we have the ascending, the lib. So it's gonna follow this prerequisite here. It comes down to here, come down to here, okay, and just take off this code. Let's just take off this code and see what happens. Make clear screen and we'll press enter. Okay, sorting is up to date. So if I do ls, let's see. We have we have our .o.menu here in this file. So it was not moved to any place, which is wrong. It's also supposed to have moved to the object, because if we list the obj, I don't think there's anything inside it. So there's no file inside it. So we bring up our make file now. Let's see why it's not moving. Let's put it like this. We say -o. The same thing here. Say -o. No, it's wrong. It's wrong, guys. This is very, very wrong. So we are like outputting. So this is wrong. So what I will just do here now is I will just create a file called I'll call this objects. Okay, objects. Then this objects will be the one to move. Okay, so if I press enter, I'll say objects column. Then here I will now do my move. Say mv, we are moving the /source ascending underscore sort. Okay, then we say .0. So we are moving it to the ./obj. So if I just move it to ./obj, that's all. Then we are moving all files. Inside this we are moving all files inside here. We are moving /host file *.o with .o extension into the obj. That is what we are doing. So when this output is done, the file is being stored. I'm taking off these two. So this will just move all files to there. Let's run this program and see. So we type the make. Okay, source obj file cannot state .0 no such files. Okay, but if you look at the files are here, they are living here. So what we just need to do is that we just move these files here. That we are saying in this current directory. Okay, in the current directory called in this current directory we say in this current directory, okay, all file with .o extension, move it to this file. So let us see if it works this way. We say make, and that has been moved. It works. So if we do ls now, those files are no longer there. So if I do ls obj, now you will see that we have those files there. So they were moved actually. Okay, so if I do make make clean, it will just delete those files as well. Remove obj, remove this, cannot do rf by sub because no files is there though, so it can't remove. But if we do the ls obj, you will see that those files are gone. So we just do the make again and see the build. So it builds well. Now if you do ls and ls obj, and there we do ls then lib, we should see our object file. Okay, now we don't have the share library as well, so we need to create a root for the share library also. So I'll clear the screen. We type vim vim uppercase vim uppercase vim uppercase m, and we go back now. So we'll now create a rule for our lib. Okay, so this is the lib. All right, when we come there, we do cgc shared dash o, go to the lib pen.o. It's not taking this file, it's not running this file. Let us see why it's not. Let us run the code again and see what happens. So I will do make clean, we do make clean, we do make clean. Okay, so we remove those. So if we type make now, let us see. Okay, ascending and moving, but the library is not executing. Okay, the library is not what executing. So now we are going to look at the lib. Okay, we go to our make file. So the lib is the problem, or why we are not generating it. So which is this? Okay, which is this? So we come down here, the lib, we say we are using the gcc dash shared dash o, and we are using all object file here. Okay, it's not doing it because it's the way the order of execution matters. So we are supposed to like put object before lib. So we take off lib, then we put object before lib. Now I think everything will work fine now. Okay, so press enter, let the screen make clean, and that is done. Now if we type make obj move sending sorts, okay, we do ls lib, there is no lib file. Let's go back to the make file. Okay, so if lib should be the first, the first to execute, then I think object should be moved first before we can or maybe we should first of all, for insertion key, we should do everything asterisk dot o, which is inside this directory first. Okay, then we put lib before objects. Okay, so let's see. Make clean, clear, then type make OVP objects, we do ls lib. Okay, it's not generating the output of what we want. So you see cannot go to bin. Okay, line 22, let's look at that error. Okay, this program is getting more longer. Let us the make it just giving us a little bit headache. So we are gonna fix it, guys. Let us fix it real quick. Okay, this is what we are gonna do. Okay, since those files have been generated, we're just gonna take off this lib. Hi, we're just gonna take off this lib. Okay, out of the way. Okay, and we're gonna come here and say gcc dash shared. Okay, then we say dash shared. We are saying we are taking the from dot forward slash obj forward slash asterisk dot o, that is all file with dot o extension. We are putting it to dot forward slash lib forward slash pen forward slash pen lib dot so. Okay, so this is what we just happened. So once all these menu are done, take off the lib. Once all these menu, all these prerequisites are done, the program will work proper. So let's try and see. So we type make, clear the screen. Okay, it now works. So if I do ls lib lib, you should see the lib pen lib.so. So I clear the screen. So if I do make clean, it will just clean. Okay, so it's trying to tell us that they cannot move forward slash bin this to this directory. Okay, all right. Make 19 clean error 1. So that's where we are getting error. So we just fix that. So make 19 and this is 19. So this code here is not working because we have not yet created this code. Okay, so we need to create a rule for that as well. Okay, so since we have all this, okay, since we have all this, we are just gonna say let's all this now, let's all this be here be called, let here be called sorting. Okay, sorting underscore, and that is it. And here will be called all, the make all, and at here we can as well assign sorting. Okay, then at the bottom of it, we will now have the gcc. Okay, we say dot forward slash scr. Now we are compiling the sorting dot c, and we are outputting it to dot forward slash bin slash sorting, the name of the program, space dot forward slash, giving it with a lib pen lib dot so. Okay, so this is how it should look like. This is how it should work. So it should be make all, not make al. Make all. So escape. So let's run it now. Make clean, make all. Let's enter. Okay, so the share object, this no such files or directory. Make a share object, line 16 sorting, line 6. Okay, 1 2 3 4 5 6. Okay, sorting will not be the first, it should be the last. So I will just take this off here. I should say let sorting be the last, and I will just copy this code, escape YY, we'll just delete this I for insertion key. I will delete this, then I will go to the bottom after the object and press enter key and press escape and press P. Go up here and type I, then sorting space column. Okay, let's run this code now. So we type make all. Okay, now our Makefile is now working properly. So let's fix code related to our program. Okay, inside our program. Okay, so let's look at where we are getting error. We are getting error in the include.h error file. Okay, that we use a dot instead of a comma. Okay, here we say too many arguments to function. Okay, we use dot instead of dots. Okay, let's feed that. That is a very small. Let's go to dot / I'll go to include directory vim pen.h, and you can see the error there. Here we are supposed to put comma. Okay, we are supposed to put comma, went and put dot, so that's the error. Okay, we go back, cd one step backward, and type make. Let's see the other error we are getting. Okay, programs now works fine. So if I do ls bin, we have our executable bar fine. If I do ls source, we have our .c file. If I do ls lib, we have our shell library. If I do ls obj, we have our object file. If I do ls include, we have everything well set. So now we can run this program by do ./bin sort, and let's see how our program runs. Now it's asking us installing Figlet. Okay, installing, the English is not correct. Installing Figlet. They say press 0 for Android or press 1 for laptop or desktop. So I'm doing this in my Android smartphone, so I'll just press 0 and it will just install Figlet from us from the web. So you watch now, Figlet is now being installed. Okay, see, getting Figlet, and once it's done, it's asking us if you want to continue the download. I press Y, yes, which it will prompt you, but I'll fix that error though, so I to stop prompting you those error. Now you can see we have sorting in very beautiful form, and we have the menu outline here. So when it's asking us enter your choice, so I will do in ascending order. So if I press 1, press enter, I say allocate memory space. So I will just say 4. I press enter, so it's now ready to receive input. I will say 3 space 7 space 2 space 9 9. So this is 4. So if I press enter, it arrange it in a horizontal form, which is this is what we call runtime error. So we're just gonna fix this error, okay, in our program. It's supposed to be 2279. Okay, 2279. Okay, so we just go and fix that. All right, so to fix that, we change to our source, where we have our printf. Include, we do vim ascend.c. So I will just go down. I fixed a new line. I'm not supposed to fix a new line here. Okay, so I will just do this, and that is it. Then after everything is done, I will now print f. I'll say /n/n, and that is it. Okay, escape shift column. We also do that in the vim descending order .c. Okay, see the hustle we went through to fix bug in our code, which is something everybody will learn to do. So I'm just making this video more real, Remember, I told you that it's going to be more real. Okay, I'm not editing anything in the video. I'm just going to leave it to see how I was able to fix the error and make everything work fine. So I will do another printf, then backslash double quote /n /n, and that is it. So we close this, and that is it. So the next error is in the, I think in the vim sorting.c. So we are supposed to figure the installing in English is incorrect. It's supposed to be ing. Installing Figlet, we just put ... to make it more beautiful. Okay, and I think that is all. So there's another thing I want to fit. Let it don't ask you the why to continue, because most of you might not know. Upgrade and update -y here too, minus here they will not be -y, but in the upgrade they will be -y. Installing Figlet, they will also be a -y. So we also do here also, I will just put this in separate lines. Yeah, I'll put -y, -y, and here also -y. So that is why I will not ask you if you want to continue and all that. So that is it. Clear my screen. I'll just type make to rebuild the program again. Oh, sorry, I have to move one step backward. So I'll type make, and the program is built. Then if I do ./bin /sort, where the program is, there are programs. I say, do you want to install Figlet? I say yes for Android 0, and I press enter, and it's installing it, getting the IP of the Temos.net. Okay, to run this program you need to have internet, please. So guys, you must have internet. If you don't have internet connection, you will not be able to install Figlet. So wait for it to install. It's like I'm running out of data. Okay, so we wait for it, it will still install. Okay, wait for it, we wait for it. Yeah, ignore, it's ignoring. I'm running out of data. I can look at my data bundle from here. So I'm running out of data, so that is why it's saying a git ignore, but it's going to work because it's already installed already. So what it's going to do is that it's going to check all those errors, but the program is going to run because it's already installed. So make sure you have correct data installed in your laptop. Okay, remember I'm doing this video with my Android phone, that's why I'm choosing Android. Okay, so if you are doing it with so okay, see, it works. So we have our sorting beautiful, and every upgraded. Then we can now choose, let us choose the first one we choose, which is the ascending. We press enter. We are allocating memory space. Let me allocate 5. So press enter now. I'm gonna input my value. I'm gonna say 10 space 4 space 3 space 2 space 0. Is this up to 5? 1 2 3 4 5. Yeah, so if I press enter, you see we have 10 4 3 2 0. Okay, this is giving us in ascending order. This should be the way of descending instead of ascending. So I'm just going to change that, and I'm also going to put space so that it looks more beautiful. Okay, so I'll do / source. Yeah, source. I'll do vim ascending.c. I press enter. Then I will just come here. Okay, when it is being printed, let there be space. So I'll just put space. Okay, we just put space, and that is it. So that is the correction of that program. So since this is ascending, it's supposed to be the other way around. Yeah, so if the second one is greater than the first one, no, we say less than. Maybe here we should do, we are storing this. If it is less than this, if the first one is less than the second one, if it's less than that of I, then we are moving store this and we store temp in I. Okay, if this is greater than this, okay, the code is correct. Let me just look at somewhere. There's a place I'm thinking of, the vim sort, maybe it's from there. If I did it well, it's one is ascending and 2 is descending. Okay, so let me go and see this program why it's behaving that way. So if I run the make again, so I need to go one step backward. Type make, enter, we build /bin /sorts yeah, 0. We just have to pass through that process of installing. But I will just upgrade it. Yes, if installed, like if the program is already installed, we just skip all this process than making sure that all this process run. But you see everything is working. So we say, I'll just say 1. I will say 1 and I press enter. Memory allocation, let me say 4. I'll just give like 2 space 1, make this more smaller, make it more smaller. Okay, 2 space 1, 5 3, that is 4. So you see, it arrange it in the ascending order. Okay, it's arranging it in the ascending order. We'll run this program again, and yes, 0. We'll run this program again, it starts, then we say we are choosing 2. Let's see what will happen. Then we say we are allocating 4. We say 2 space 1 space 4 space 6, which is 4. Is now arranging it in descending order. So we are making mistake here in order of descending and ascending. That's why I'm making mistakes. So I will just change to source and /. I'll just change to source and I will do vim ascending.ci. Then here of our source code, we change it to greater than. Okay, and we save that, and we go to the vim descending. Under the here, we change it to less than. Okay, and that is it. cd ... type make, and that is built /bin /sort. So I'm using Android to build it, to write this code. So the program starts. I say here 1 for ascending. I'm locating 4. I will say 4 space 2 space 1 space 0. So let's see. Now you see it's now arranging in descending order, in ascending order. So we have 0 1 2 4. Okay, we're now working very fine. Now you see how this program is working very fine. What if in a case whereby we want to say the descending? Okay, so we say 2 is for descending. We choose, sorry, input, you see wrong input because we give it wrong inputs. Okay, so the program is working very fine. So we have to say 0, it's install unnecessary stuff, and it starts. So I'm entering 2 for descending. Let me say I'm allocating 7. I want to allocate more than 4, so 7. I'll say press enter. So I have to put my input. I'll say 2 7 6 1 8 1 2 3 4 5 6 8, and I will say 5. So I think this is 7 1 2 3 4 5 6 7. So press enter. Now you see it's giving us in descending order, but there is no space. So that is the place we are doing error now. So we have to fix that also, guys. A lot of fixing of these are normally what I face when writing code. Okay, I make mistakes in where I'm supposed to put this and when I'm supposed to that is just how we forget things. But when running the program, we fix our runtimes error. So I will go back to, I will say vim source / descending. So I will just go down, okay, and this is where I got it wrong. I'm supposed to put space, okay, and press enter. Then I type make build the program, and I type ./bin /sorting and 0 because I'm using Android. If you are using laptop, you use 1. So I say yeah, the 2, which is descending, and I'm allocating. Let me allocate 10. Okay, so I will say 20 space 50 space 10 space 500 space 3 space 2 space 1 space 0. This up to 10. I think this is 8 space 6 space 9. 1 2 3 4 5 6 7 8 9 10. Yeah, so I'll just press enter. See, it's arranging it in descending order, which is 550 20 10 9 6 3. So the program is running effectively and very, very powerful. Okay, I hope you guys love this video. In my next video, what I'm gonna do is that I'm gonna show you guys, I'm gonna allow you guys to clone this code. So what I'm gonna do is I'm gonna push it to my GitHub, then I will present the code to clone it, and you make and run these programs in your machine, in your laptops. Okay, so bye bye guys. It's been educational hanging out with you guys. So please make sure you subscribe, like, share this video, and also drop your comment below on what you don't understand about this program. Okay, all right, but before we go, there's something I'm supposed to write, which is called the readme. Okay, which I forgot. Let me just write that real quick before we summarize. So readme is called the readme.markdown. This tells us how to run this program. So I'll use the vim to open the readme file. So press enter, I for insertion key. I'll say this is a readme. So this is when you clone this program, this is the first file you should look at, the readme. So the readme says that first build the project. Okay, build the project. Build the project. So press enter. So first of all, we say run this make. Okay, run. First of all, when you clone this, you change. First of all, change.
If I know how to do what?
Change into the hack paste cloned directory.
Are you interested in learning the fundamentals of
Hack paste clone hack paste clone directory. Okay, change into the
Are
hack
you
paste
interested in
clone
learning the fundamental
clone directory. Okay, so to change into the hack paste clone directory, just put column here. Put column, press enter. So to change that, you run this command called cd. You run cd hack paste. Okay, and that will take into the hack paste directory. Then once you are done, to execute, to build, you say to build the program. To build the program, you run make, and that's all. And lastly, to execute the program, we say you should run this dot /bin / sorting. Okay, so this is a makefile on how you should build this project. Should write it in uppercase letter. Okay, say build the project. All right, so this is a simple makefile that just illustrates how you build the project. Okay, so first of all, you change to the directory. Second, you run a run make, and thirdly, run dot /bin / sort. Okay, and that is it. All right, so I hope you guys love this, and if you love this, make sure you give me a thumbs like, you follow me up, you subscribe to my YouTube channel, and expect more of things like this. Okay, so see you guys on my next video. Have a great day. Bye. Escape, shift column, and I will save this. So when you clone, you change it to the directory, you cut the readme.markdown, and you get the output on how to run this program. So have a nice day, guys. Goodbye. Be blessed.